Hello, this is Rochelle Mitchell, and in this video we're going to talk about simplifying complex fractions. We're going to do that in two different ways. In this first video, we're going to talk about simplifying a complex fraction using division. So, right here, using division. A complex fraction is a fraction that contains smaller fractions. So these would be what I would call the smaller fractions. And the big fraction is that whole numerator over that whole denominator. So these lines are for the big fractions, and the other little fractions are what I call the little fractions. So our steps that we're going to take is we're going to rewrite the complex fraction as a division problem. So if we look at this very first example, what that's going to look like is we're going to take this numerator, so 1 over x minus 1 over x squared. And then we're going to say that because this symbol, when we have a fraction like 1/2, that's 1 divided by 2, we're just going to rewrite this as divided by the quantity 1 over x minus 1 over 2. Then what we're going to do is we're going to find in the first expression, we're going to find the least common denominator. And if I look here between these two denominators, my least common denominator is going to be x squared. So I'm going to need to rewrite these with x squared in the denominator. Now, if I look at this second one, that is x squared. So my first one, I'm going to need to multiply the top and bottom of this by x. X times 1 is going to give me x. And so now they have the same denominator. And we're going to go ahead and add or subtract. In this case, we're going to be subtracting. So what that's going to look like is that's going to look like just the numerator. And then since they have the same denominator, we can write it over one denominator. Then we're going to do the exact same thing. We're going to find the least common denominator for the second expression, least common denominator. So if I look at 2 and x, the least common denominator is just going to be 2x. So I'm going to need to rewrite these with 2x as my denominator. I'll go ahead and leave this division symbol here. Well, what this first fraction is missing is a 2, so I'm going to multiply the top and bottom by 2. And this second guy is missing an x, so I'm going to multiply the top and bottom of that by an x. So, again, if I rewrite this, this would end up being 2 minus x in the top, all over the common denominator. Now we have a division problem, and when we're dividing two fractions, we simply take, we want to invert the second fraction, also called finding the reciprocal, taking the reciprocal of the second fraction, and that will turn it into a multiplication problem. Multiplication. Wow, that was more challenging than it needed to be. So it's going to become x minus 1 over x squared times 2x all over 2 minus x. Then we're going to simplify by canceling any common factor. On the top and bottom. We have to think of those as complete factors. So realistically, this denominator I could rewrite as x times x, and the only thing I can cancel is 1x here and the x on the top. So that's going to give me my final answer of being 2 and that x minus 1 on the top, and in the denominator, x and 2 minus x. In the next video, we'll talk about how to do this in a different way. But let's go ahead and get a little bit more practice here. So if you remember, the first thing we're going to do is rewrite this as a division problem. So I'm going to rewrite this as 1 over x squared minus 49 in parentheses, divided by, and then in parentheses, 7 minus 1 over x. I'm going to try and color code the same way here. Then I'm going to find a common denominator between the first two, the first expression, I should say. That would be x squared. And we could think of this as over 1, so we're going to multiply x squared on the top and bottom. So that's going to end up being 49x squared, and that's going to be a 1. We're going to do this same thing to the second fraction. The denominator, since that's over 1, would be x, and I'm going to multiply x over x and that first guy. And if we rewrite this, this would just be 1 minus 49x squared all over x squared. And then this would be 7x minus 1 all over x. So now I'm going to rewrite it as a multiplication problem. Now, before I can cancel factors, I might need to factor. So before I rewrote it, but that denominator is just x times x. So I can see that might cancel here. And this guy is the difference of perfect squares, and that's going to factor into 1 plus 7x and 1 minus, ooh, goodness, I forgot the 1. 1 minus 7x. So if I look at what I can cancel, I can definitely cancel an x here. I kind of erased it. But these guys look very similar, but they're not exactly the same. So I have to have them look exactly the same in order to cancel them. So I'm going to go ahead and factor out a negative 1. Whenever they look kind of opposite of one another, if I factor out a negative 1, this is going to be negative 7x plus 1, which could be written in the different order of 1 minus 7x. So then over here, remember I have x. I have 1 plus 7x and 1 minus 7x. God, I keep forgetting that 1. And now they look exactly the same, so I can cancel them. Oops. This x is no longer there. That's just a 1 on top. So my final answer ends up being 1 plus 7x all over negative x. We could also write that negative in front, and we could have also written it on the top. And that's how we're going to simplify complex fractions using division.